Welcome back, everyone, after the coffee break. We have now a session about natural language processing, and we have three interesting speakers there presenting their lightning talks from already published papers. And the first speaker in this session is Gustavo Penha, and he will present his work that was published in Rijke this year together with Claudia Hauff. So Gustavo, you can share your screen and start. If anyone would like to ask a question, would be nice if you could post it already in the chat during the presentation, and then Gustavo can answer your questions or the other speakers after the presentation.
Yes.
Okay, Gustavo, go ahead. Welcome.
Thank you, Suzan. So I'm going to present our paper on probing BERT for conversational recommendation. I'm a PhD student at TU Delft, supervised by Claudia, as you said. And first I'll talk about the problem. So conversational recommendation is when there is one user who is seeking information and he engages in a dialogue to do so with an information provider. So here I have an example. So he says, I'm looking for a 90s film with a great soundtrack. I thought Power Rangers and Turbo were masterpieces of cinema, mind you, and I'm looking for movies from that era with great music, so dramas, thrillers, road movies, adventures, and things. And then the information provider will give recommendations. So he says that you should seek fiction, and this conversation can go on. So a closely related field is natural language processing. So a recent breakthrough in NLP has been heavily pre-trained transformer models. So BERT is an example of those. So the pipeline is usually to the first step. This model is trained on a lot of data and with a lot of GPUs, and then the weights are released. So anyone can use this model to fine-tune for their own tasks. This has been shown to be really successful. And also recent research has shown that there are also knowledge stored in the parameters of this model after the first step. So if you don't do any fine-tuning, you can also already extract knowledge from BERT, for instance. So if we want to know in which city Rembrandt died, we can feed BERT this sentence and mask the token that we want to guess. And we pass this through BERT or another language model, and the highest token will be the guess from the language model. In this case is Amsterdam, which is a correct prediction. So here in our paper, we would like to use this power of such pre-trained language models for conversational recommendation. And we first study what those models know about recommendation items in 3 domains. And we do so by introducing some probing tasks. And I'm going to talk about them now. So we introduced 3 different probes. The first one is the general probe. So here we are interested in seeing if BERT already captures the relationship between movies and their genres. So let's say that BERT is able to do that. We think that this will help BERT or another model to match the request with the potential answers. The second probe, we call it the search probe. And basically, we want to see if BERT has already knowledge about the content of the item, the recommendation item. So here, if we have, for instance, data set with a lot of reviews for Pulp Fiction, and on those reviews, we see that there's a lot of mentions to the music, the songs, and if BERT is able to match this with the item, we hope that this will improve the recommender system, a conversational recommender system. And finally, we have the recommendation probe. So here, based on interaction data, so let's say movie lens, we get those items that are frequently watched together based on several users, and then we ask BERT if it is able to match those. So if we know that Power Rangers Turbo are frequently watched with Pulp Fiction, this would help a conversational recommendation system to deliver this answer. So in order to actually test BERT for those knowledge, we need to use sentences because that's all the language models receive as input. So we need to construct some prompts. So for the genre, we just follow previous work, and then we put the item title here in this template. So here is the Wind Up Bird Chronicle, which is the title of this book. We say that it's a book of the genre, and then we mask the token of the correct answer. We do this with the other domains as well, for the movie domain and music album domain. And for the other probes, we need something different because we are not comparing any more tokens. We don't want tokens as output. So we do something here that we call relevant pairs and non-relevant pairs, and we want BERT to score the relevant ones before the non-relevant pairs. So for search, we combine the title of the item with the review, and then we get a random item and use this as a non-relevant pair. And for recommendation, we do similarly. We use the titles of movies that are or items that are consumed together, and then for the non-relevant pair, we just select a random item from the data set. So those are the prompts, but we need to extract this knowledge from BERT. So in order to do that, we rely on BERT's pre-training heads. As I said in the beginning, we are not fine-tuning BERT for any of those tests that I showed. We just want to see if the pre-training captures this already or not. We have more details but in the paper, but we do 3 different techniques to extract this knowledge from BERT based on the different heads that we have here, and also the representation. But I will leave that for later. And then the research questions that we answer in this paper are: how much knowledge does the BERT store in the parameters about the items to recommend on those 3 domains? And how can we infuse knowledge into BERT so that it's able to be better at conversational recommendation? So I'm gonna go already to our findings and some of our experiments. There are more on the paper, but I summarized here some of them. So the first one is about the genre probe. So here we use the baseline of the prior distribution. So we do not tell the title of the item to BERT. So here the template would look like this. So it is a book of the genre, and then we mask the token. And we see that because we say that it's a book, BERT already is able to find relevant tokens, the category tokens for those domains. However, when we actually use the title of the item, so we put the title here instead of it, we get much better effectiveness. So this is evidence that BERT indeed has category information or general information about the items, storing parameters. So we didn't fine-tune, we just used the pre-trained weights. And for the search and recommendation, we have more details of this on the paper as well, but we saw that there's more, BERT is more effective for search, the search probes, which we believe it's expected since BERT is actually a language model, and the recommender part of it is not that strong. So moving on to the next question. Here we are actually fine-tuning BERT for this task. So the task here is that given the context of the conversation, which is what has happened so far in the dialogue, we want BERT to distinguish between the correct answer. So this is the answer that a human-to-human interaction actually happened, and a negative candidate, which we sample using the context, the whole context as query to be identified. So here in this example, the user says hi, and the other says, hi, what type of movie would you like to see? So I'm looking for Star Wars, but not Star Trek. And the top answer is the correct one. The second is the negative sampled. And if we train BERT to do that, we actually see that it's able to distinguish between the correct and negative candidates with very high effectiveness. But we did something else to make this test a little bit more difficult. So instead of using the negative candidates, we do some adversarial candidates, where instead of getting a new answer completely, we simply get the correct answer, which makes sense in the dialogue. However, we just randomly select a movie from the database, which makes this a negative candidate because we are just recommending random things. So if we do that, BERT actually is not able to distinguish between the correct answer and the adversarial candidate. As we see here, the effectiveness drops by quite a lot. So it's easily fooled by these adversarial examples using different items. So as future work, we believe that it's important to combine recommender systems with language models because they cannot do everything by themselves. And we also think an important direction is to use language models for explainability. So why am I receiving this recommendation? And also test the same setup that we have for different domains and different language models as well. So that's it. I'll be glad to answer any questions.
Hi, yeah, thank you, Gustavo. That was very interesting and insightful. So I would like to ask, there are no questions coming in yet, at least not with the delay that we are experiencing. So let me ask my first question. That was really interesting what you did with the probing. About the adversarial example that you had, so you showed that the BERT was very effective in distinguishing the PM25 positive and negative examples, but then you said that the adversarial example was actually a random pick from the items.
Yes.
And in what sense would random be adversarial?
Yes, because except for the item, the rest of the dialogue is the same. So we just change the recommendation. So it's as if it makes sense in the dialogue, what BERT said, the adversarial candidate, but we just pick a random item, which doesn't make any sense in this conversation. Like, so it's not like it's using the context to give the item. It's just picking randomly. So, yeah,
okay, in that sense. Okay, yeah, I know the term adversarial as something that is on purpose difficult to recognize. But okay, I see what you mean. And now there are two questions actually in the chat. So Robin asks, would it be possible to use BERT to predict genres for titles it has never seen during training?
Yeah. So if I understand the question correctly, is that the pre-training procedure, the data that you used influences a lot on the results of the probe. And if it hasn't seen anything, yes, it wouldn't, we don't expect it to be able to do that. So this relies a lot on what BERT was pre-trained on. So it was pre-trained on Wikipedia and a data set from books, like the actual books, the text from the books. So yeah, we did some analysis as to what was in that data set and correlations with the response, the effectiveness of the probes. So, but it's quite difficult to find the exact data that BERT was trained on. There's no like public release for the exact data. So we tried to do this correlation analysis, but it didn't go into the paper because there was no significant correlation. But yeah, the idea, I think that the answer for this question is that it wouldn't be able to be effective for something that it hasn't seen.
Yeah, to be honest, I'm not sure. I mean, if parts of the title are actually known, I mean, parts of the title will be known words and have known meaning, so it might still be possible in some cases that it guesses the genre right. Yeah, I would be my guess. But so the final question is from Zoltan, and he asks about how this approach would work for domain-specific models, and then in particular the biomedicine domain.
Yeah, I think it makes a lot of sense. You can test this for all kinds of domains and see what has been stored already in BERT. I think this is quite interesting. It probably will fail in a lot of domains because we know now that the BERT is not really a general language model. If we test this on medicine, I'm pretty sure it will fail a lot. And it would be.
Yeah, but of course with the BioBERT model then.
Yeah. So with models that are adapted, then this is a little bit different, because maybe we are kind of already using that data. Then of course we expect it to improve. So let's say if I train BERT for the probes that we have, I expect it to be good at those probes. And this is actually something that we did. But that doesn't necessarily, in our case, for instance, translate to conversational recommendation effectiveness. We have some experiments about that on the paper. So we actually train for the probes, but then still BERT is not able to do what we would want it to do in our case.
So this might also be something to discuss further later during the poster session. And the same holds for the question that Arjen poses about personal preferences. So I suggest you take that up later. And for now, I thank you, Gustavo, for your interesting and clear presentation. And we are going to the next speaker. And that is Emma Gerritse from Radboud University. And she will present her paper that she wrote together with Faegheh, Hasibi, and Arjen de Vries, published at ECIR this year.
Yes, thank you, Suzan, for the introduction. You already told the title of my paper, which I'm going to present. And I'm going to use now the title to explain how this talk is structured. So first, I'm going to tell you what entities are. Next, I'm going to tell you a little bit about graph embeddings, which we're going to use. And last, I will tell you how we combine that all to entity retrieval. So first, I'm going to explain what entities are. So entities are can be anything like people or buildings or events, like DIR 2020. If you want the shortcut definition, it's generally everything which has a Wikipedia page. Could be just to get an intuition of what an entity is. Wikipedia, as you are all familiar with probably, is a knowledge base. And there are also many other knowledge bases like Yago or DBpedia. And the nice thing about knowledge bases is that they're structured as a graph. So you know what the links are between entities, and you also know what the relation is between those entities. So we're going to do entity retrieval in this project. And entity retrieval can be seen as a subset of document retrieval. So in document retrieval, the documents are stored in some database, but in entity retrieval, they're stored in knowledge graph. So we have some extra information. In document retrieval, we have unstructured documents, but entities are more structured. If you look at Wikipedia, all the entities have like around the same structures. And we also, like we said before, know the relationships which the entities have to each other. So this brings me to the research questions we have. The first one is, does adding graph embeddings improve entity retrieval methods? And then the second one is, which queries are helped the most by that? So now I'm going to explain which kind of embeddings we use. There are different types of entity embeddings. But the ones we use for this work is Wikipedia to Vec, which is based on Word to Vec. So it bases on Word to Vec, the general skipgram model, where you try to predict a word depending on the context. But then it adds two parts, which adds the link graph. So that is the neighboring nodes of the entities in the graph. So for example, in this Plato example, it adds all the other famous Greek philosophers. And then also to combine the entities and the words into the same model, we combine that with the anchor text. So if you link to a page on Wikipedia, you always have an anchor text explaining how those pages are related to each other. And using those three, we can combine them to a model where the entities and the words are embedded into the same space. So to get this to work into entity retrieval, we need to first know which entities are present in our queries. And for that, we need to do entity linking. And for the entity linking, we use TagMe, which then links in short sentences the possible entities to the actual entities. And it does that with a confidence score. So in this sentence, who is the daughter of Bill Clinton married to? It links the entity daughter with a confidence score of 0.13. Bill Clinton, it's a bit more certain about, and then married to, it's not linked correctly. It's linked to same-sex marriage, but it's linked with confidence of 0.21. Now, how do we combine that to a score? If we want to rank the relevance of an entity to a query, we have to look at the similarity of that entity to all the linked entities in the query. So if we take, for example, the entity Chelsea Clinton, we want to compute the score between that and the entity who's the daughter of Bill Clinton married to. We have to compute the similarity times the weight of the confidence score of all the entities it's linked to. So, and then using this, you get a score. And the intuition is that if the entity of Chelsea Clinton is relevant to this query, it will be closed in the embedding space to all the entities linked in the query. So, which queries are we going to evaluate this on? We were using DBpedia entity version 2, which is a collection with around 500 queries, and we have around 50,000 query entity pairs, and they're all ranked with relevance score of not relevant to highly relevant. And the queries are collected from 4 different data sets, and it can differ a lot how many relevant entities there are per query. So all people named Jimmy has almost 1,400 relevant entities, but something like Spring Shoe Canada has only 1 relevant entity, and it has everything in between of the number of relevant entities to the query. Next, I'm going to explain what kind of experiment we run on this. So with Wikipedia to Fact, the nice thing is that you can compute both embeddings with and without the graph context. And this we wanted to use to compare if it's just the embeddings we use or for specifically the graph embeddings. So we compute both of those and then re-rank the top 1,000 result to compute the score. And then we evaluate it using NECG at 10 and at 100. And which score are we then going to compute? We're going to combine, since we're doing re-ranking, we're going to combine a previous score, like for example, FSDM or BM25. And then our query-based score, which I explained previously, which then computes the similarity between a query and entity. And we have to compute this lambda to make a linear combination, which we do using coordinate descent in RankLib. And here you can see for the different types. So the C is just the word embeddings, and the CG is with entity embeddings. That, for example, with BM25, the entities have a lot of relevance, while with FSDM and only the word embeddings, entities add less because the lambda is lower. So I'm going to show you the big result page, which often occurs in papers, but I'm trying to break it down. So here we have the results. Here are the regular scores without the embedding part. And then next part I show are the scores with only the embedding, so without combination. And you see that just the embeddings don't score very well. But then if we combine them, we see that we do get an improvement. And the biggest improvement is seen in BM25. So next I want to tell something about where the entities are actually situated in the embedding space. Because we want to see if we can see some difference how those entities are embedded. So here I have a UMAP plot where we cluster all the entities relevant to the same query together, and we try to plot them in UMAP. And you do see that all those different colors are entities relevant to the same query, that they cluster together in a UMAP plot. And this is the one with the graph structure. And then if we look at the embeddings without the graph structure, you see that it's much more mixed. So the graph structure really seems to add something for the entities which are relevant for the same query. There are some more explanations in the paper, but unfortunately I have to skip them through time. And we also looked at some of the false positives, the highly ranked false positives, which you do see are embedded close to the entities relevant to queries. So the ones with a black circle around it are false positives. So you see that they often occur next to the entities of the query, but that's understandable because, for example, for the query South Korean girl groups, the false positives are SHINee, which is a South Korean boy band, or Hyuna, which is a South Korean female singer. And it's logical that in the embedding space, these would be close to each other, although they are not relevant to the same entity, or to the same query. So last, I'm going to explain a little bit what went well and what didn't went well. An example of an entity which improved a lot is which instruments did John Lennon play. So then the linked entities are John Lennon and musical instruments. And then the closest entity to that is John Lennon's musical instruments. So that's exactly what we want. And what doesn't go well is sometimes the entities are wrongly tagged because entity taggers are not perfect. Sometimes the entity linker prefers the wrong entity, so entity which is not very relevant gets a very high confidence score. And lastly, some of the entities are not embedded. So with that, I'd like to conclude my work and tell you what we're still working on. So entity embedding does improve entity retrieval mostly, so this improvement is significant. And the entity embeddings fit the cluster hypothesis. If you want to learn more about that, please read the paper or ask me. And what we still want to do in the future is use better entity linker. So for example, the Rapport entity linker, which I'm shamelessly going to plug here. Check that out if you haven't already. And other embedding methods. And then lastly, we want to check how other we can use the embeddings, because now we had a very simple similarity score, but maybe you can do something more fancy to compute the score. And with that, I'd like to conclude this lightning talk. So if you have questions, please ask me here in the comments or send me an email, or I will also in the Gathertown later. Yeah, thank you for listening.
Great, Emma, thank you very much. That was really interesting. And actually already a question came in during your presentation by Fabian, who is asking, was the Wikipedia graph automatically generated based on links?
So the Wikipedia graph is generated based on the links in the Wikipedia graph. So for example, if you have the page of Aristotle, then it links in the page to philosopher, then Aristotle and philosopher have a link to each other. I hope that explains your question.
We are going to wait for his answer.
Okay.
Vera is asking, are you considering nil entities, or does every entity have a match in the knowledge graph?
I'm not sure what you mean with nil entities.
Like that you recognize an entity in an entity mentioned in the query, but you also recognize that you don't have a representation for that entity in your knowledge graph. That I think is what she means.
Yeah, so unfortunately we don't have a representation for that now. So I did skip those slides. We do have, I checked, we have embeddings for 98.7% of the entities in DBP, entity collection. So we only miss around 1.3%, I think, with these embeddings. But that definitely was a problem because most of the default embeddings missed a lot of entities. But right now, for that small percentage which we miss, we just embed it with 0. So then, unfortunately, not much happens.
Mm-hmm. I have a little specific question in your example of the musical instruments. Mm-hmm. Can you go back to that? So this is probably something that I missed in the explanation of your method. So,
okay.
So this is which instruments did John Lennon play, and then you found two entities, right? John Lennon and musical instruments, and those were correctly linked. And what exactly is the result you found? Is that also an entity, or is that a document?
Yeah. So the results are entities, but in the scores we use for re-ranking, there they did use the documents to compute those scores, because the entities, of course, have also like a page with information, so you can use those for sort of regular document retrieval methods. But the results are entities. So the entity closest to the entity John Lennon and musical instruments in the embedding space is John Lennon's musical instruments, which then becomes the top-ranked returned entity.
Okay, no, I understood that, but what I then wonder is, why is that not linked from the... Right, I see, so you linked John Lennon and you linked musical instruments, but you did not link John Lennon's musical instruments. You got that through closeness from... So what is the difference then?
Well, it's not linked because our entity... like the easiest answer is because the entity linker didn't link it. Because all the entities are linked with an entity linker.
Okay.
Yeah.
Okay. Yeah, I'm just thinking about the difference between answer entities and query entities in a way.
Yeah.
So here maybe the example is a bit confusing because actually the answer entities is so literally similar to the question entities, right?
Yeah, so the question I had before was who's the daughter of Bill Clinton married to, and then it computes like the same, like the closest entity to daughter and Bill Clinton, which is actually Chelsea Clinton.
Yeah,
so that's maybe
that
a
makes
handier
more
example.
Actually, so that I was confused with that. So let's do the one final question by learner on .NET. So I'm not sure who that is, but do you think the graph enrichment of embeddings would also lead to improvements in search of entire documents?
We're actually working on that.
I was thinking that already. Yeah.
Yeah, cool. We're working on that. So hopefully probably in half a year or something, hopefully you can see a paper of us on that. So hopefully, I'm not telling too much what we're doing, but we're working on that. So
so this is actually an important direction right now, like the improving document retrieval with knowledge graph information, right? So I was already hoping you were going to take that up.
Yeah. Great. So there's a paper already on that, which is a thing called Word Entity Duet from a few years ago, which does something similar to that. So there has been some work on that. Yeah.
Okay. Well, great. Thank you very much. That was really interesting. I will applaud on behalf of everyone. By the way, I see people in the chat pasting clapping hands. It is colon clap colon. If you type colon wash hands colon, you get also something like this. So some people are actually washing hands instead of applauding. But thank you, Emma. And we're going to the third speaker. And the third speaker of the session is Maartje ter Hoeve. And she's going to present her work that was published in Cheer this year, together with 5 or 6 co-authors. On conversation with documents and exploration of document-centered assistance. So Maartje, go ahead.
Thanks Suzan for the great introduction. So you've already said what I wanted to say in my first slide. So I'll be presenting our work on conversations with documents, exploration of document-centered assistance. So I'm a PhD student at the University of Amsterdam, but this work was done during an internship I did at MSR, and it's joint work with Robert Sim, Elnaz, Nouri, Adam Fourney, Maarten de Rijke, and Ryen White, and it was indeed first presented at Cheer. So to start this presentation off with a quick motivating example, consider the following scenario. A person is on their way to a crucial business meeting to prepare for a day with potential investors, and the person is co-authoring a document about their company that will be provided to its investors, and that document will be finalized in this upcoming business meeting. The latest version of the document is just being sent by email to the person's managers, and to be optimally prepared for the meeting, the individual wants to review what is already in the document. However, they're driving, so they do not have direct access to the document, so they call their conversational assistant. And the person might ask questions such as, does the document already mention the mission of our company? Or summarize what it says about our growth in the last 2 years. But at the same time, they're unlikely to ask factoid questions, such as who is the CEO of our company, given that they're already familiar with the organization as they work there, so they won't have this type of information need. So we call this type of assistance document-centered assistance. And despite a great focus on digital assistance in all kinds of other areas, document-centered assistance has not seen the same kind of progress. And that's the reason why we focus on it in this work. Now, I know by now I need to make a small disclaimer here, because I know I will get questions about this otherwise. The example with the car is just a motivating example, and we do not mean to implement this just right out of the box without any research on how safe this is. And there are actually a lot of people doing very interesting work on these kinds of questions. But that's not really the point of this research. And of course, you should always keep the safety in mind. And this is just meant as to sketch a scenario where you can only interact with a device via voice assistant. But there are, of course, tons of moments where you have that, like maybe you're cooking or cleaning the house or whatever. So with that remark, going back to the main slide, so the difference between document-centered assistance and most existing Q&A systems is that these existing Q&A systems often focus on more factoid type of questions. So they can be answered with just a couple of words, like what is the capital of France? Paris. Now it's nice to see that over the last year, actually many more directions have been coming up, apart from only factoid. But what makes document-centered assistance different is that it really aims to help a user with editing a document, and that a user is not expected to use it to ask for encyclopedic answers to these factoid questions. So that's the other example that I give on the slide. Like, does the document already mention the mission of our company? And it's like, yes, on page 2 it says blah, blah, blah. But that's just an example. And at this point, we don't really know what users would really like to ask in such a document-centered scenario. So that is why we divided our research here in 3 steps. So in the first step, we conduct a survey where we ask users what kind of features they would find helpful and what kind of questions they would ask about the document in such a document-centered scenario. And then we did a data collection step where we collected more questions and more answers. And we used that in step 3 to do some initial baseline experiments to actually model this document-centered QA task. And this was all in the outlined scenario, but we made it a bit more general to fit a bit of a wider variety of documents. Now, to start off with the first part, the survey, we had 23 participants in a judging environment comparable to Amazon Mechanical Turk. And the participants were all English-speaking, US-based, trained to do the task, and paid an hourly rate. So that was nice because there was no incentive to rush responses, so we got very high-quality answers. Now, we had quite some questions, so please refer to the paper if you're interested or ask me later. But here we ask participants to show that they what they would find helpful in such a document-centered scenario. And we see that users would find capabilities such as summarizing or reading parts of the documents, or navigating to specific parts of the documents and answering general questions about the document most useful. But yeah, for more results, please refer to the paper, because now I want to go to the next part of the survey where we aim to get a better understanding for the types of questions that users may ask. So therefore, we collected questions that are grounded in specific documents, and participants are again primed with the same scenario, which is simulated by presenting them with an email in the format that you see on the slide. And it contains the document introduction as a means to give participants some context about a specific document to ensure that they're able to ask informed questions, but at the same time, they should not have full knowledge about what is written in the document, as otherwise they cannot ask any questions anymore. So like this, we arrived at 2,000 questions. And we divided participants' questions into this question hierarchy. So on level 1, we see the document-centered questions, factoid questions, mechanical questions, and other questions. So I'll give an example of all of these on the next slide. And then we also, because we're in the end interested in the document-centered questions, we also had a level 2 where we divided those up, and one of them were like the closed form yes/no questions. And as we figured that participants or users of a system, if you ask something like, does the document contain information about X, and you say yes, then you might actually want to know what is that information, right? So we divided these closed form questions again up in the rest of the categories of level 2, and that was then level 3. So as promised, quickly some examples. So for a document-centered question, that would be, so these are verbatim examples actually posed by the participants of our study. Does the document have specifications to the type of activity and sector improvement that will be offered? A factoid question could be, what is the date of the festival? A mechanical question is like, highlight capability workers, and the other questions are more questions that are not directly referring to the content of the document, such as read the email to me. Then if we quickly have a look at the distribution of questions, what we can see is that, for example, on level 1, the document-centered questions form the majority of the questions, the largest category. So that's indicating that it's important to be able to answer these types of questions. Now, we'll go very quickly onto the data collection step for time reasons, but again, please refer to the paper if you want to know all the details. So here we added more questions for an additional 36 documents, and that brings the total number of documents to 56, 20 from the previous round. And we also collected answers for all of these questions in the same crowd working platform. And then we call the collected data set document question answering, or DQA for short. So the data set consists of a bit over 16,000 questions, and we had a nice variety of open questions, closed form questions, and unanswerable and answerable questions. And as I said, we're going to use this data for the modeling stage and to run some initial baseline experiments. And we focused on passage ranking and answer selection. Again, for the sake of this presentation, I will focus on the answer selection part, for which we use BERT large. And then we had a few settings. First, we fine-tuned BERT large on our new DQA data set and evaluated on DQA. Because our data set is not so large, we also experimented with including larger data sets. So specifically, we fine-tuned it on the larger SQuAD 2.0 data set, which is a data set that is comparable to ours in the sense that it also includes these unanswerable questions, but different from ours in the sense that it's factoid questions and not these preferred document-centered questions. We also have a combination where we combine SQuAD 2.0 and DQA, and then, of course, evaluate on the DQA holdout set. And lastly, we also did some query rewriting for all these three settings, and to make the questions in the DQA dataset look a bit more like factual questions by deleting document-specific n-grams, such as does the document. Right, so for the results, again, the result table. So what we see is that fine-tuning BERT on SQuAD 2.0 and DQA significantly outperforms the other settings. And we also see that the query rewriting does not perform as well as we hoped. And we think that that is because our query rewriting at this stage is still a bit too naive. And yeah, we hope to experiment with that in future work. And another thing to note is that we can see that the scores are still quite far away from what we know from the SQuAD 2.0 leaderboard. So that indicates that we found an interesting problem, and that is definitely something to still work on. So now, to quickly wrap this all up, we have seen that there is a need to be able to answer document-centered questions, and we collected a new data set that includes these document-centered questions and their answers, which we call DQA. We saw that this task is very challenging and has many practical applications, so that can inspire a lot of new research that we're very excited about to work on. And for now, we've seen that fine-tuning on SQuAD 2.0 and DQA performs best, but yeah, there is still a lot of work to be done, so we're excited about that. So that's it. Thank you so much for listening, and I'm happy to take any questions.
Cool. Thank you very much, Maartje. Maartje, that was very interesting. I really love this task. It's completely new to me, and that's very nice. This was some very cool typical cheer work where you had a survey. And while we wait for comments in the chat, I would like to ask something more about the data collection stage. Of course, you went quickly over that. So did you use crowdsourcing for that?
Yeah.
And then first in the survey, you had a number of, 2,000 questions. And then for the data collection, you collected some more, right? 16,000. Yeah. And was it with the exact same procedure?
Yeah. So like in the beginning, we had this stage where we also asked, for example, these capabilities, like what kind of features would you like, or those kinds of questions. These we left all out, and we just really only focused on the document, and now ask 5 questions about this.
I see. Cool. And did you also ask them to select a ground truth answer?
Yeah, exactly.
Okay.
So yeah, you're absolutely right. I went super quickly over this for the sake of time, but we built some kind of tool where they could kind of select answers, and that was then the answer to that question. So first we had a round where they asked new questions, and then once we had these questions, we kind of put that again back into the platform, and then we asked them to answer everything.
And so, and how did you do that for questions like, please summarize the document for me, or that was just not allowed to ask questions like that?
Yeah, so it was indeed extractive at this point. So in that, like, people could select a number of different extracts from the document. So they would have like an extractive summarization.
Oh, cool. So Arjen actually asks, how difficult do you think it would be to move from a single document to a small folder of documents, for example, user's Dropbox?
Yeah, so that's a great question. Thanks, Arjen. I personally think that it's not, for this task, I don't think it's more or less difficult than for any other task that goes from single document to multiple or multi-document. Intuitively, I would say that. That said, I think what I like about this task is, one, I find it very interesting, but secondly, it also shows the limitations of like the models as we know it. So I also think that just, and that has partially to do with the fact that it's just very exploratory, so that I still have many ideas on what you could do. But I think it's also important to kind of first try that and then maybe add more documents. But yeah, like if people want to work on this, then
yeah, well, not only exploratory, but also incredibly versatile, right? Because you left it really open what kind of questions people would ask. And
exactly.
I think that makes it very difficult and also very interesting. So it's really nice, I think, that you started so broad, just asking people, what would you like to have?
Yeah,
really cool.
Thanks. That's nice that you appreciate it. I like that too. And we actually had a didn't make it to any presentation, but it's in the paper. Like we trained some kind of quick like linear regression classifier, like nothing fancy, to see whether we could classify the different types of questions, and that actually worked surprisingly well. So you can also think about it more from a like system-C perspective, that you might first have this classifier and then kind of fire it to different types of systems, because maybe
like answer extraction or summarization,
exactly,
or reading aloud or marking. Okay, cool. So let's take the final question here from Johnny, who is asking, do you know how much the performance may be improved by using more DQA data? If the squad dataset is more factoid based and using improved performance, maybe the DQA is too small, I think, relative to the squad.
Yeah, no, you're absolutely right. Thanks for this question. I couldn't agree more. I think if you add more questions, more answers, it's gonna be better, definitely. That said, two things here. So on the one hand, I think it is also important to look at these kinds of scenarios, because we can simply not always collect a new data set for the new thing that is kind of similar, but differently enough to completely break existing trained systems. So I do think it's important to look into this space by not having so much data. From like a pragmatic point of view, but also just from a point of view that we as humans would not need a completely new training round to now do this task. And yeah, the second thing I wanted to say, I forgot.
Well, I think that answers the question already. Actually, there's one more question, but I suggest we move that to the poster session later. So thank you, Maartje. I applaud and wash hands on behalf of everyone. And also thanks to the other speakers, Emma and Gustavo, that I think was really 3 nice presentations. So what we're going to have next is the poster session. That will last until 12:30. There's actually some really nice posters already being set up. And the environment where we are doing that is gather.town. You can find the URL in your email. Please do not share the URL publicly, like on Twitter or here on YouTube, because we want to avoid abuse from people who have not registered. And after the poster session, there will be a lunch break. If you like, you can go to Gather and then speak to people there. It works really nicely. And we continue with more lightning talks at 2:00. So let's see each other in gather.town and speak to some people and view some posters. Thank you.